Hi everybody, in this lesson we go over the reciprocal trigonometric ratios. So first off, let's define what the cosecant ratio is. The cosecant ratio is equivalent to, or the cosecant ratio of the angle theta is equal to 1 over sine theta, but it's actually defined to be r over y. Now because sine theta is just y over r, cosecant theta is the reciprocal of sine theta. So an important thing to note is that cosecant theta is used to denote 1 over sine theta. And just to re-emphasize this, I know that I talked about this in a previous video, but sine inverse theta is not equal to 1 over sine theta. This is absolutely not true. Okay, if we wanted to write this in terms of sine theta, what I could do, and using an exponent, what I could do is I could write sine theta in brackets to the power of -1, or take the reciprocal in sine theta in brackets, and this would be equal to 1 over the sine of theta. Okay, so just to clarify, this is really important. A lot of students tend to mix this up. So another reciprocal ratio is called the secant ratio, and the secant ratio, or the secant of theta, is equal to 1 over the cosine of theta, which is equal to r over x. And notice that this is the reciprocal of x over r, which is the cosine ratio. So the secant ratio is the reciprocal of the cosine ratio. The cotangent ratio is the reciprocal of the tangent ratio. So the cotangent ratio is 1 over tan theta, which is also equal to x over r, because the tangent ratio is, not x over r, x over y, rather. The tangent ratio is y over x, so the reciprocal of that is x over y. And cotan of theta is the reciprocal of tangent theta. Okay, so let's use this in a couple of examples. So here it says, determine two possible angle measures between 0 and 360 degrees for each equation, and it wants us to round to the nearest tenth if needed. So the first thing that we're going to do is we are going to rewrite the secant of theta in terms of sine theta or cosine theta. So in order to do this, we can write secant of theta as, if you go back up to the definition, secant of theta is 1 over cosine theta. So we have that 1 over cosine theta is equal to 3. Now, in order to solve for theta, we're going to take the reciprocal of both sides of this equation. And so we know that cosine theta is equal to 1 over 3. All that I did is I just took the reciprocal of both sides of the equation. So now that we have that cosine theta is equal to 1/3, I know that theta, one possible measure for theta, is equal to the inverse cosine of 1/3. So if on a calculator you calculate the inverse cosine of 1/3, you get that cosine, or sorry, you get that theta is equal to 70.5 degrees, where we've rounded or we've approximated theta. So we get that theta is equal to approximately 70.5 degrees. Now, here we found one possible angle measure for theta between 0 and 360. So one possible angle measure is 70.5 degrees. We also need to find another possible angle measure. So we have to think where else is cosine theta positive, and we know that based on the cast rule, that cosine of theta is, or the cosine ratio is positive both in quadrant 1 and in quadrant 4. So we have that another angle measure for theta would be equal to, let me write that aside here. Another possible angle measure is that theta is equal to 360 degrees minus 70.5 degrees. So 360 minus 70.5 is 289.5 degrees. When we've rounded. So the two possible values are 70.5 degrees and 289.5 degrees. In the next question, we're asked to figure out two values for theta, where cotan of theta is equal to -5. So the first thing that we're going to do is we're going to rewrite this in terms of the tangent ratio. So we know that if cotan of theta is equal to -5, well then 1 over tan of theta is equal to -5. And we know that tangent of theta then is equal to -1/5. Okay, so we have that tan of theta is equal to -1/5. And now we're tasked with finding theta. So we could take the arctan of both sides of the equation, or take the inverse tan of both sides of the equation, and we know that, actually let me write this out. Let me write this step out. So we know that theta is equal to the arctan, or tan inverse, of -1/5, which is equal to, let me get a little bit more space here. One possible measure for theta is, if you do this on your calculator, you'll get that theta is equal to -11.3 degrees, where we've rounded to the nearest tenth. So -11.3 degrees. If we, here we're tasked with finding values of theta that are between 0 and 360 degrees. And notice that, well, here, theta is not between 0 and 360 degrees. Theta is a negative value. And that's because when I take the arctan of -1/5, my calculator spits out a value of theta that would satisfy this equation. The only problem is that it spits out a negative value. So I've got to figure out what are the positive values of theta that satisfy this equation. So one possibility is well, I know that I can find a coterminal angle. So I can just add 360 degrees to -11.3 degrees. So one possible angle that's between 0 and 360 degrees. One possible value of theta would be an angle that's just coterminal to this one, or it's the principal angle. So it's -11.3 degrees plus 360 degrees, which is equal to 348.7 degrees. And let's actually draw out the Cartesian coordinate system, and let's think about this a little bit more. So I know that tangent of theta is negative both in, it's positive in this quadrant. Remember the cast rule. So tangent of theta is positive in these two quadrants. So that means that our angle has to be either in this quadrant, which would be the 348.7 degree angle, or it could be in quadrant 2 as well. So it's either in quadrant 4 or in quadrant 2. Now the reference angle here is 11.3 degrees. That's our reference angle. So that means that another possible angle is 180 degrees minus 11.3 degrees. So another possible value for theta is 180 degrees minus 11.3 degrees, which is the reference angle, which is equivalent to 168.7 degrees. So those are our two possible values for theta. In the next question, we're told to figure out two values for theta that are between 0 and 360, such that cosecant of theta is equal to minus a half. So if we try to solve this equation, the first thing that I'm going to do is I'm going to try to rewrite cosecant of theta in terms of sine theta. So cosecant of theta is just 1 over sine theta. And that's equivalent to minus 1/2. If I take the reciprocal of both sides of this equation, I have that sine theta is equal to minus 2. Now, something that's really important to note here is that sine theta is equivalent to the ratio of y over r, and because r is the hypotenuse in a right angle triangle, and y, the magnitude of y, is one of the legs of a right angle triangle, then this ratio has to be between -1 and 1, and it can be -1 and 1. So we know that sine of theta. Let's write this up here. So sine of theta has to be between -1 and 1. Therefore, there's no solution to this equation because there's no values for theta such that sine theta is equal to -2. So therefore, no solutions.